Alright, welcome to Quideo number 3. We're going to start with the basic problem. So the first one is about a person who's investing money, and it gives us a probability distribution table with the profits, or the X, and the probability, or the Y. And we must remember that it's in millions of dollars. So I went ahead and wrote in all the zeros so I wouldn't forget. So part A is asking us to find the mean profit and the standard deviation of the profit. So the thing to remember for this is that the mean is found by multiplying each possible value by its probability and then adding all the products together. So here I wrote it all out and I multiplied them all and then I added them all and the answer is 3. A tip for this, the mean of X, we have to remember that it's in millions of dollars and it's not just 3. Okay, so now for the standard deviation, we have to remember that you can't just add the standard deviations together. So instead we use this add square root formula. So, and then I also wrote the instructions on how to do it on your calculator, and then I wrote it out how to do it by hand, and that gives us the variance, so we have to remember to square root that to get the standard deviation, which is $2.52 million. Yes. So then part B is asking us, it gives us a formula, and it says that he owes its source of capital fee of this plus 10% of the profits. So the 10% means that he keeps 90%, so that's where this 0.9 comes from, which would be the slope, because if you notice this is in the slope form, and this would be the y-intercept. So they want to know the mean and the standard deviation of y, which I have here. So the mean, you just simply plug in 3, which we found from up here as the mean, and it gives 2.5. And remember the context of the problem, so add all the zeros. And then for the standard deviation, you simply just plug and chug, and it yields that. Now for the advanced problem, it's asking if the problem's about an insurance company that makes an annual profit of $150 on each homeowner's policy with a standard deviation of 6,000. So A is asking the reasons that may contribute to such a large standard deviation, because 6,000 is kind of a big number. So up here, I said that one of the possible reasons that could contribute to such a large standard deviation would be the values that are either way smaller or way larger. So in context of the problem, that must mean that most of the losses will be very small or even zero, with a couple big losses from maybe like a natural disaster. That doesn't happen very often, but it does happen. So the insurance company, the loss would be large. So for B, it asks us if it writes only 2 of the policies, are the mean and standard deviation, what are the mean and standard deviation? So tip for this, I'm assuming that the policy profits are independent, meaning that they don't affect one another. So I'm going to let X to the 2 be the profit from policy. Oh my gosh, that should be a 1. So X to the 1 is the profit from policy 1, and then X to the 2 the profit from policy 2. So the for the mean, you just add them together. So 150 plus 150 is 300. Now, remember it asks for the standard deviation, so we have to remember that the standard deviation simply finds the variances, and then you square root it. So square add square root, which I worked out here, and that's what it yields. So for part C, it asks if the company writes 10,000 of the policies, what are the mean and standard deviations of the annual profit? So here, I wrote out what the mean would be. You simply add them all up for 10,000, and you get this large number. And then for the standard deviation, it's pretty much the same thing as the problem above it, except for the 10,000 policies, and this is what you get. It's quite a big standard deviation, if you notice. So part D is asking is the company likely to be profitable? I said that the company is likely to be profitable, and my reasoning was that if they sell 10,000 policies, they come because the expected value is that, and the standard deviation is that, which we found from the problem before. So if you plug that into the z-score formula, you get negative 2.5, which means that a 0% or a $0 profit is 2.5 standard deviations below the mean, so that would mean that it's most likely a profitable insurance company. So for the AP question, it's about tractors and the energy that they need to pull a plow. And so it has they're testing two different kinds of hitches that would connect to the tractor and the plow. And they're trying to reduce the draft so it uses like less energy. And they had two different plots and two different hitches. So A is asking what the response variable is in the study to identify the treatments and what the experimental units would be. So remember that a response variable is typically the y value, whereas the explanatory variable is typically the x variable. So the response variable in this situation is the amount of draft, or the amount of energy that you need to pull the plow. Also remember that the treatments are what is being used to test in the experiment. So the treatments are the standard hitch and the new hitch. Also remember that the experimental units are the objects being experimented on, and that they're called subjects when the experimental units are humans. On this problem, the experimental units are the two different plots of land. So B says, given that the goal of the study is to determine whether a newly developed hitch reduces draft compared to the standard hitch, was randomization used properly in this study? So I said yes, because the two hitches, or the treatments, were randomly assigned to the two plots or experimental units. Then on to part C, it says, given the goal of the study is to determine whether a newly developed hitch reduces draft compared to the standard hitch, was replication used properly in this study? I said that the replication was not used properly in this study because the two types of treatment, or the hitch, was applied to only one experimental unit, or plot of land. The purpose of replication is to repeat the treatment on different experimental units so that different patterns can be observed. In this experiment, there is not enough replication. So for part B, it asks, the plot of land is a confounding variable in this experiment. Explain why. So the plots of land were confounding because the experimenter did not know what environmental conditions such as soil type, terrain, or moisture could have varied from plot to plot, which would ultimately affect the results.